Hello everyone and welcome to another Math tutorial video. Now I'll be discussing Form 5 Additional Mathematics, Chapter 8 Kinematics in a Straight Line, Long Question Example 1. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question now. A particle P moves along a straight line that passes through a fixed point O. Its velocity v meter per second is given by Vp is equals to 3 plus 5t minus 2t square, where t is the time in seconds after passing through point O. Particle Q moves along the same straight line. It begins from point O with a velocity of negative 2 meter per second at the moment particle P passes through point O. Particle Q moves with an acceleration of a meter per second square, which is given by AQ is equals to 40 minus 4. So the question asks to find the velocity of particle P when it passes through point O for the first time. For the question part B, the time when particle P reverses its direction. For the question part C, the total distance travelled by particle P in the first 5 seconds after passing through point O. And for the question part D, the velocity of particle Q at the instant the velocity of particle P is a maximum. So this is the overall question. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solution. So without further delay, let us start to solve the question. For this question, as we all know, we are dealing with the two particles, which is particle P and Q. But for the question part A, you just have to focus for the particle P itself. Okay. So as you can see here, the question asks us to find the velocity of particle P when it passes through point O for the first time. Okay, this point O is indicating the starting point of a straight line, and it mentioned here for the first time. Okay, this first time it's indicating when your time is equals to 0 second. Your starting point at time is equals to 0 second, guys. Okay, so this is the clue given by the question. Okay, so since it involving the velocity of particle P, so let me write down the equation of the velocity of particle P. So given that Vp is equals to 3 plus with 5t minus with 2t square. Okay, let me box this. Okay, so since you have your time is equals to 0 second, you just have to substitute into this equation. So let me write the working here. For particle P, when t is equals to 0 second, okay, you just substitute into the equation. So in this case, it will become initial velocity of particle P. So it will be V naught. Okay, V naught will be equals to 3 plus with 5 times with 0 minus with 2 times with 0 square. So from here, you should get your V naught is equals to 3 meter per second. Okay, so this is your answer for the question part A. So let me underline the solution. Okay. So from here, let us proceed our discussion for the question part B. Okay, for the question part B, we are still handling the particle P. For now, they ask us to find the time when particle P reverses its direction. Okay, I just want to let you know that for this chapter, you need to be careful for the keywords. Okay, most of the clue are hidden within the keywords over here, guys. Okay, so you need to be careful when you're reading the question. So in this case, they mentioned that the time when particle P reverses its direction. So this statement is actually indicating that your velocity is actually equals to 0. Okay, and then you need to find the respective time when your velocity is becoming 0. Okay, if you still don't understand, okay, let me give you a quick example. Okay, let's say this is your particle. Okay, it's moving in a straight line direction. Okay, it's moving up to this point, and then after reaching this point, it need to turn. and then once it complete the turn, and then it will come back to this same point itself. Okay, this turning point is the point where your velocity will be equals to 0. So I hope you understand the concept which I'm trying to explain to you. Okay, so let us proceed to our working. So like I mentioned, when the particle reverses its direction, your velocity will be equals to 0. Okay, so let me write the working here. For particle P, reverses its direction, so from here it will become your velocity is equals to 0. So this is your main information. So let me box this. Okay, so the velocity equation for particle P is already mentioned in the question itself. So let us write it down. So from here 3 plus with 5t minus with 2t square should be equals to 0. Okay, so you move all the variables in the left hand side to the right hand side. Okay, so from here you will get 2t square minus 5t minus 3 equals to 0. Okay, as you can see, we have already formed the quadratic equation. Now for the next step, what we're going to do is we're going to perform the factorization for this. Okay, so you factorize this quadratic equation. So from here you get 2t plus 1, okay, and then you get t minus 3 equals to 0. Okay, from here you get two possible answer. You get either t is equals to negative 1 over 2 or t is equals to 3. Okay, but you have to be very careful. Your time can never be a negative value. So since your time can never be a negative value, so this negative 1 over 2 can never be a solution. So you can only have one possible solution where t is equals to 3. So let me write the statement over here. So from here your t will be equals to 3 seconds. Okay, so this is the only answer you can obtain. So let me underline the solution. Okay, so from here let us proceed our discussion for the question part C. For the question part C, we are required to find the total distance travelled by particle P in the first 5 seconds after passing through point O. To solve this question, the first step what we need to do is we need to find the displacement of particle P. Okay, in the question they only give us that the velocity equation for the particle P is equals to 3 plus 5t minus 2t square. So from this velocity equation, how are we going to find the displacement equation? It's very simple, guys. We just have to integrate this equation, and from there we should be able to get the displacement equation. Okay, so this is the overall idea. So let us begin our discussion for the question part C. Let me write the working here. So step 1, find the displacement for particle P. Okay, so given that your displacement is equals to integration of velocity with respect to time, so let me box this. Okay, so from here S is equals to integral of, okay, let me substitute the velocity equation into the working here. So given that velocity of particle P is 3 plus with 5t minus with 2 t square close bracket with respect to dt. Okay, so from here let us continue. So for the next step, what you're going to do is we're going to perform the integration. So you integrate this integral. So from here you get your s is equals to 3t plus with 5t square over 2, okay, and then minus with 2t cube over 3, and don't forget to put the plus c as well, since this is an indefinite integral, guys. Okay, so from here up until now, I hope you guys are clear about this. So for the next step, what we're going to do is we're going to include an important information. So take a look at the statement here. It mentioned that a particle P moves along a straight line that passes through a fixed point O. So that means that your particles start to move at the point O itself. So this means that when time is equals to 0, your S, or also known as displacement, is equals to 0. Okay, so this information you need to include in the equation here, guys. So when t is equals to 0, so your S is equals to 0 because your particles start to move at the point O itself. Okay, so you substitute everything, you get your C is actually equals to 0. So from here, your displacement equation of particle P will be equals to, okay, let me just copy paste this. (3t) plus with 5t square over 2 minus 2t cube over 3. Okay, so this is your equation for particle P. I mean the displacement equation, guys. Okay, so let me box this. Okay, so from here, once we get the displacement equation for the particle P, so for the next step, what we need to do is we need to calculate the displacement traveled for the first 5 seconds. Okay, so we need to calculate one by one. That means for the first second, how much is the displacement, for the second second, how much is the displacement, and so on until it's come to the 5th second. Okay, so we need to calculate them one by one, guys. Okay, so from here, let me write the working. So step 2, okay, so from here, let us begin when the time is equals to 1 second. So from here, when t is equals to 1, where t is equals to 1 second, so from here, your displacement is equals to, okay, you substitute the 1 into the equation here. So from here, 3 times with 1, okay, plus with 5 times with 1 square over 2 minus 2 times with 1 cube over 3. So you calculate this, you should get your displacement is equals to 5 over 6 meter. Okay, so this is for the t is equals to 1 second. Okay, let us proceed to the t is equals to 2 seconds. So when t is equals to 2 seconds, similar step, guys, you need to substitute the 2 into the equation here. So from here, your S is equals to 3 times with 2 plus 5 times with 2 square over 2 minus 2 times with 1, should be 2 here, 2 cube over 2, over 3. So you calculate this. So from here you get your displacement as is equals to 10 2 over 3 meter. Okay, so similar step for the t equals to 3, t equals to 4, and t equals to 5. Okay, so let me perform the working here. So just follow up with me. So when t is equal to 3 seconds, okay, so you calculate this, you should get your displacement is equals to 13 1/2 meter. Okay, so let us continue for the t equals to 4 seconds. Okay, so you calculate this, you should get your displacement is equals to 9 1/3 meter. When t is equals to 5 seconds, so okay, you calculate this, and is equals to 3. Okay, you calculate this, you should get your displacement is equals to negative 5/6 meter. Okay, so this is the complete working, guys. I know it's a tedious step, but in reality you no need to show this long step, guys. You just have to key in your calculator and it will save you a lot of time. The reason why I'm showing you this step-by-step working, so that you will able to understand better. Okay, so once you've already calculated the displacement traveled in the first 5 seconds, so the next step what you're going to do is we're going to sketch the motion diagram. Okay, so please wait and I'll come back with the motion diagram. Okay, I've already completed the motion diagram sketch, so let me show it to you now. Okay, so please wait. So this is how your motion diagram should look like for the particle P. Okay, let me explain it from here itself. Okay, so this is actually indicating the position O. So your particle will start to move from position O when the time is equal to 0. Okay, and then it moves in a straight line. Okay, at t is equals to 1, t is equals to 2, and up to t is equals to 3 seconds. Okay, once it has 3 equals to 3 seconds, okay, it's having a turning point and it starts to move in the opposite direction. As you can see here, when t is equals to 4, your displacement start to reduces. Okay, until when you see the t is equal to 5 seconds, it starts to move in the opposite direction. The displacement is totally in the negative region. Okay, in this case is indicating that the particle is moving in the left direction instead of in the right direction. Okay, so I'm showing you in these two paths so that it will be easier for you to understand. Okay, so I hope you guys understand the working I'm trying to show to you. Okay, so from here we need to find the distance traveled in the each interval respectively. So from here let us calculate the respective interval. Okay, so from here 5/6 meter. Okay, you minus with 0 meter, so from here you get, okay, of course 5/6 meter. Okay, so the next interval will be 2/3 meter and 5/6 meter, so you need to minus them both. So from here 2/3 meter, okay, you minus with 5/6 meter, so you calculate this, you should get your answer is 5/6 meter. Okay, let us move on to the next interval. Okay, the next interval is 13 1/2 meter and 2/3 meter. Okay, this interval, so let us perform the calculation. So from here 13 1/2 meter, okay, you minus with 2/3 meter. Okay, you calculate this interval, so from here you should get 2 5 over 6 meter. Okay, so from here let us move on to the next interval. Okay, the next interval is involving 13 1 over 2 meter and 9 1 over 3 meter. Okay, from t equals to 3 seconds to t is equals to 4 seconds. So you need to calculate them one by one. Okay, so from here 9 1 over 3 meter. Okay, you minus with 13 1 over 2 meter. Okay, then you can tell me this calculation will lead us to negative. Okay, in order to prevent the negative, you put a modulus sign. Since we are calculating the distance, right? So the distance will be positive value all the time. So you calculate this, you should get your distance, the interval is equals to 4 1 over 6 meter. Okay, and let us proceed to our last interval, negative 5 over 6 meter. Okay, and then you minus with 9 1 over 3 meter. Okay, since we are calculating the distance, what you do, you put a modulus sign. Okay, you calculate the interval between them. So from here you get your distance interval is 15 1 over 6 meter. So once you have performed this calculation, the final step is summing all the distance, guys. Okay, so from here your total distance. Okay, to calculate the total distance, what you do, you plus all these values respectively. So you calculate this, you should get your answer 32 5 over 6 meter. Okay, so this is your answer for the question part C, guys. Okay, I know it's a long working, but it's worth, guys. Okay, so let me underline the solution for the question part C. Okay, so from here let us proceed our discussion for the question part D. For the question part D, we are required to find the velocity of particle Q at the instant the velocity of particle P is a maximum. Okay, so from here our first step is we need to come up with the calculation such that the velocity of particle P is a maximum. Okay, so from here let us begin our working now. So for velocity P to be maximum, so from here what we're going to do is we're going to differentiate the velocity of particle P with respect to time. So from here d Vp over dt. Okay, and then we are going to set it equals to 0. Okay, so this concept is also known as the turning point concept, guys. Okay, turning point, which you learn in the differentiation chapter. Okay, so I hope you can recall the concept. So this turning point calculation is used to determine whether your point is a minimum or maximum. Okay, so from here you differentiate the velocity of particle P. So from here you get 5 minus 4t equals to 0. So from here 4t is equals to 5. Okay, so from here you calculate the t, you should get equals to 5 over 4 second. Okay, so let me underline this. So once you get the value of t, so now what we're going to do is we're going to perform the double differentiation, where we're going to differentiate this expression for second time to double check whether this t value give us a minimum value or maximum value. Okay, so from here to double check, so from here d square Vp over d t square Okay, so let me underline the fraction. Okay, so you differentiate this expression one more time, you should get equals to -4. Okay, so this -4, the value is actually less than 0. So when you have a double differentiation value which is less than 0, so it is indicating that it will give us a maximum value. Okay, so now we can confirm that this t value will give us a maximum velocity at particle P. Okay, so from here, for the next step, what you're going to do is we're going to use this t value and substitute into the velocity of particle Q. But then we have a problem. In the question, they didn't mention the velocity of particle Q. However, if you take a look at the question, they mentioned that the acceleration of the particle Q is equals to 4t minus 4. So from this equation, how are we going to find the velocity equation? So it's very simple, guys. We need to integrate the acceleration. When we integrate the acceleration, we can get the velocity. So that will be our second step. So from here, proceed to our step 2. Okay, so step 2, integrate acceleration of particle Q. Okay, so to find the velocity of particle Q will be equals to the integration of acceleration of particle Q with respect to time. Okay, so let me box this relation. Okay, so from here, velocity Q is equals to, okay, the integral of acceleration Q. So in this case, acceleration Q is 4t minus 4 with respect to dt. So you perform this integration. So from here you get velocity Q is equals to 2t square minus 4t. Okay, since this is an indefinite integral, don't forget to put the plus c over here. Okay, always remember this, guys. Okay, so from here up until now, I hope you guys understand the working. For the next step, what we're going to do is we're going to insert an important information mentioned by the question. Okay, what is that? So let me show you the important information. Okay, so read this sentence. It mentioned that particle Q moves along the same straight line. It begins from a point O with a velocity of -2 meter per second. So this statement gives us the information that when time is equals to 0, your velocity Q is equals to -2 meter per second. So this information we can use to calculate the velocity of particle Q. Okay, so from here, let me write in the working here. When t is equals to 0, so from here your velocity Q is equals to -2 meter per second. Okay, so what you do, you substitute this value into the equation here. So from here, -2 equals to 2 times it 0 square minus 4 times it 0 plus with c. So you calculate this. From here you should get your constant c is equals to -2. Okay, so let me underline this. Okay, so once you get the value of constant, now you can come up with the complete equation of velocity of particle Q. So from here, the velocity of particle Q is equals to 2t square minus 4t minus 2. Okay, so once you get this, now you can use the time that you get in the early of the working. This time value you substitute into the velocity of equation Q. Okay, so from here, when t is equals to 5/4 second, so from here your velocity Q is equals to 2 times with 5 over 4 square minus 4 times with 5 over 4 and then minus with 2. So from here you calculate this, you should get your velocity q is equals to negative 3.7 over 8 meter per second. So this is your answer, guys. Okay, so let me outline the solution for the question part D. So from here we do know that when the time is equals to 5 over 4 seconds, the velocity at the particle P will be maximum and the velocity of the particle Q will be equals to negative 3.7 over 8 meter per second. Okay, so that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not to forget to share this video. Thank you everyone for your support, and I'll see you in the next video.